Okay, now we're going to discuss lipids. The lipid family is very diverse. The thing that joins it together is that all of the substances are either totally insoluble in water or partially insoluble in water. So it's a hodgepodge group, a collection of many different kinds of molecules, but all are either totally or partially insoluble in water. As you can see, that group consists of the fatty acids, triglycerides, phospholipids, sphingolipids, carotenoids, steroids, eicosanoids, and fat-soluble vitamins. Each of those we'll spend a moment or two discussing. The lipid family comprises about 18 to 24% of your body. So let's think about that. I earlier said in the last video that 56 to 60% of the body is water in this standard human. Again, the standard human, 70 kilograms, about 5'8", 5'9", male, early 20s. About 56 to 60% was water. If I go past that, we said 1 to 4% was carb, and now we're saying that about 18 to 24% is lipid. Now, I don't want you to equate, those are the big time exercises, that your fat content of the body is 18 to 24%. The fat content, fats are only one subcategory of lipids. One subcategory of lipids. So this is not your fat content. As you know, that would be far too much. So don't equate those two together. All right? So here's kind of another that you can glance at, giving various things, the steroids, the phospholipids we'll talk about. Here's another chart. And again, much of this you'll have to do on your own and glance. I'm assisting. Okay, we start with the first one called a fatty acid. All right. A fatty acid is basically a long group of carbons terminating, see, that's what these functional groups came in this carboxyl group. If you go back to my functional PowerPoint video, you will find that carboxyl group is acidic because it can donate an H+. So the term fatty acid came from the fact that of this terminal carboxyl group that you have. Okay? So under the fatty acids, what you will find is that, and some are naturally occurring, generally the ones that are naturally occurring are even carboned, 12, 14, 16, and so forth. Okay? Under the fatty acids, you have saturated and unsaturated. A saturated fatty acid has no double bonds. So whoever came up with the term said is saturated in as many hydrogens as possible. If you had a double bond, you couldn't put as many hydrogens, therefore unsaturated. If you only had one double bond, then you would be monounsaturated. If you had several, you would be polyunsaturated. Okay, so read on that. Okay, so as we look at it, here would be fatty acids right there. Okay, a saturated fat. Saturated fat would have a bunch of hydrogens. So I now go to an unsaturated fatty acid and a double bond there. A double bond. So we could, if it's only one, a monounsaturated. Now, when we look at the saturated fatty acids, no double bonds, nature likes to bend these molecules, as it did with the carbohydrates, into a configuration that is thermodynamically favorable. When you don't have any double bonds, it's easier to bend these single bonds. So it would go together like in a clump. So what's my point in this? That a saturated fatty acid, no double bonds, will bend into a clump, so it is generally solid at room temperature, like Crisco, shortening. A polyunsaturated fatty acid, as you can see like here with double bonds, can't bend as easily, and because of that, it's generally liquid, like Wesson oil at room temperature. So unsaturated ones generally are liquid, and saturated ones, and your saturated ones generally are solid. Okay? Now, the unsaturated ones, like this here, in the cooking industry, they'd like to make some unsaturated ones saturated for cooking purposes. Take it from oil and more of a solid. So that's where the hydrogenation process came in foods. Hydrogenation, adding hydrogens. The problem with the hydrogenation process, which they didn't realize initially, is that many of the hydrogens are added in a trans form, if you call cis-trans. Not the cis like I'm showing here, but a trans form. And if you recall, you may have heard that trans fatty acids, as a result of this hydrogenation, are the ones that kind of cause hardening of the arteries and so forth like that. So I'm just pointing out some factors that you may have already heard. Here again, unsaturated oil. Right here, a saturated, see, a solid like this right here, this butter. Okay, just pointing out things. An essential item when we come into, even with the amino acids we'll get to, means that your body cannot make it. Many things in your body can be bioconverted. That means you take one thing and enzymes convert it to another. However, certain things you must eat in the diet. Two fatty acids that are essential that you must eat in the diet are linoleic and linolenic. Linoleic and linolenic. Okay. Some will add another one called arachidonic. But it's questionable because arachidonic acid can be made in the human body. But you'd have to have taken in linoleic, which is a essential. So really two straightforward essentials and one quasi-essential arachidonic. Now this guy right here, this arachidonic, is going to be real important in you because that's going to be the mother one to make something called the eicosanoids that you're going to hear. So keep that tucked away in the back of your mind. Okay? So I go further then. Here's the essential fatty acids. Two families, omega-3, 6. That's where you, remember that omega was, where is the double bond from the end? Where's the double bond from the end? Remember the omega, alpha, omega, first part, the Greek alpha, omega, the end. Omega numbering. Where's that double bond from the end? Type of thing. So that's what you're looking at to show. Here's that omega right there. See that first double bond? That's an omega-3. See what that double bond is? Each of these corners right here is a carbon. Let me point that out again. You're not doing face to face. But whenever you see something drawn, whenever you see this, that right there is a carbon. That's a carbon. That's a carbon. That's a carbon. See, we don't put the carbons in because we're drawing fast, but that's a carbon. So wherever you see a corner, that in fact is a carbon. This is slide 79. I'm going to flip back up for a moment. So you see right here, each of these are carbons. They're using even that, just to show you. Okay, we just don't do it. We do it quickly, so you have to understand that. Okay. All right. So now, again, speaking of the fatty acids, here's the omegas of importance, omega-3 that you'll see. And again, this is good cardiovascular protection. Now, I'm not going to ask you to memorize all of that, but this is a good PowerPoint slide, PowerPoints to have when you take your nutrition or other courses. Try to put this together in such a way it would help you not only in my course, but other courses too. Polyunsaturated. Polyunsaturated. Remember the cis versus trans. Omega. Already discussed. Here again, cis arrangement. Both sides the same, but you have to have a double bond. Here's the trans. See how it comes in now? Cis versus trans. Trans fatty acids, some consider not good cardiovascular protection. There's again a discussion on trans you can read. All right, we go a little further now, And now I'm going to introduce what we're going to call triglycerides. Okay, now let's look at what we have here now. What a triglyceride is. As a matter of fact, remember, you store your carbohydrates as glycogen. Lipids in the body are stored, when it comes to energy, in the form of triglycerides. They are the storage lipids for humans. Glycogen is the storage form for carbs. I try to reiterate, just like I would do in a regular face-to-face. Trying to make this as face-to-face as I can without you seeing my face. And triglycerides are composed. So a triglyceride is composed of a glycerol molecule. Now this is called glycerol. Consider, I look at the triglycerides like a bookshelf with books. The glycerol, let's say, is kind of like the bookshelf. What I'm going to do is come and hook the books on it. The books would be the fatty acids. So a triglyceride is a glycerol with 3 fatty acids hooked to it. Now, here would be the glycerol, as I've tried to draw out here. Here would be a fatty acid. Now notice what I'm doing. I'm turning the carboxyl group, the acidic part, around. Now we're going back to this taking out the water deal. So this and this would go together. You would take an H2O out. Okay, you had 2 H's, 2 O's, which would then leave just an O. So you removed water, as we said, a dehydration synthesis. This particular water is called metabolic water. See, you do make water in your body that you don't drink or take in with your food. It's called metabolic water. We'll discuss it another time more in A&P 2. So you've now that put the first fatty acid. Here's the second one. Here's the third. All right, now listen to what I'm going to say. Because you took the carboxyl group away and put it in water, then you neutralize the acidities. Let me say that again. You neutralize the acidity because you took the acidic part off. So another name used in the clinical situation of a triglyceride is a neutral fat. N-E-U-T-R-A-L. Why? Because you've taken the acid part off and neutralized it. You've taken the acid part off and neutralized it. Okay? So that's what we call a triglyceride. And you can see that again here. These are triglycerides. That's the way you store. All right? So I'm going to end this one there. My next subject for the next one will be phospholipids. So what we've discussed fatty acids, saturated, unsaturated, and then we came in and we did triglyceride, storage fat, and showed how you added to make that occur. So now we'll close here.